I I have my headphones a little wonky. This is my ear here. Going to be getting the stitches out tomorrow, so hopefully it'll be able to heal the rest of the way. At least I hope. There are parts of it that are just like itchy, just like, I don't know. In the healing, it's bizarre. Anyway, so here we are. I've not really done anything to the chemical plant at all after the last stream. I did work a ton on the charger, the LV charger. Robert started like a little modding project for like a power suit, like power armor, and it was having some issues getting it interfacing with the charger, you know, in a way that worked really well. So I've sort of overhauled that, and I included so anybody out there who wants to create a chargeable item, there is a base object now that you can use instead of just item, right? Instead of creating an object and deriving it from item, now there is an item chargeable base class. That is an item, but it incorporates my interface and it incorporates all of the code that's needed to charge it. Okay, so you don't really have to do much else other than know that your current power here, the way that items work, and the reason why this had to be done in a unique way was all of the variables that that are stored, right? So like a block entity, when that's saved to disk, it's saved to disk as a block entity. The block entity object, like you can save and store that stuff to disk via the from and to tree attributes, right? You can override to tree attributes and save it to disk. Items don't have that, right? Items don't really have that. So how do you track variables like power? How much power is in a tool or some object? Well, that's only done through the attributes. And that is only done through the stack, right? It's not the item. I can't do this. If instead of stack here, if I did this dot attributes, it would be valid. This dot attributes does exist. Items have attributes. However, they would not be unique attributes to an individual item. They would be attributes for all of items of that type. So you have to base it off of a stack, not the class, not the item itself, but the stack that you're passing in. Okay? So this is just returning the current power, and so current power is a attribute that is set and read anytime you change it, right? So there's a set power here that you have to pass the stack in, but then you pass in how much power. And I can add helper functions to this if people need easy ways of doing this. But like the rated power here, or no, the receive power, right? So this pulls the amount of power, and where is it? Minus current power stack, blah, blah, blah. And then boom, it sets power. It decrements power. New power is current power plus power offered, and then set power, and then boom, you're done. And then boom, you're done. So these calls automatically set that variable and increase or decrease as needed. And so, yeah, it works really well. I've tested it. I got it up and running. But this is the new base class. for for simple items, or if you have a way more complex class system for items, then you just have to use this interface here and basically copy and paste this code. Like, this is very, very straightforward on how this works. And there's a lap goblin that's visiting me. So yeah, it's just a little bit more robust, a little bit better and easier to manage, because you can just grab the current power. So in an item like a suit or something, where you have some sort of tick event that happens that sees, hey, is this object being used? Or if it's a tool, for every block broken, you would decrement power. And so you would grab current power, decrement it however much you want, and then set power back. And that's the interface, right? And it's, the attributes is just basically a JSON tree. Setting values and stuff is fine. I don't anticipate any crazy situations there, but do understand that the server takes precedence. You want to only change the value on the server and then mark the slot dirty. That resyncs it with the clients. Marking the slot dirty. Because the server always overrides the client. Lap Goblin has landed. She's not going to be there long. So that was kind of an intermission on the chemical plant work, is getting the LV charger a little bit more polished. It just took somebody trying to use it. That's kind of where my attention, the squeaky wheel gets the grease. So if people try to use stuff and they find issues with it, then that actively tells me somebody's trying to use it. So it's makes me want to fix stuff. Okay. So chemical plant. This is a beast. This thing is a beast of a job here. But we might be able. I'm just trying to get 24 references. Oh, I'm just trying to get situated here. Trying to remind myself what I've been doing. Okay. Yeah, fan matching recipe. So, find matching recipe here. I do believe we have the recipe in recipe chem plant. Yes, we do. Okay. So we go back. Let's pin that. Let's go back here and find our inventory stuff. Do we have... We don't have a region for recipe. There's a machine state. This doesn't have any... Okay, there's tree attributes. Where is recipe stuff? I guess we don't have a recipe stuff. Okay. So, how about we wrap... Find matching recipe. That must be an inventory. Yeah, this is definitely an inventory stuff. Okay. I want to put this in its own region. we go. Okay, so find matching recipe. What do we want to do in here? Well, I have so many other machines that do exactly the same thing. I think it would behoove to actually look at some of those implementations. And the latest one would be the distillation tower. Now, there are definitely aspects of this that we do not need, especially like the extensions and stuff. Okay, so then we want to go chemical plant. Why is this open? Chemical plant. Find matching recipe. Okay, so we got to do some sanity checks. If API equals null, or API dot side does not equal dot server, return false. No, we don't want to do server. The clients are going to want to do this as well. So if API equals null, this is a check because this call can be run before everything is loaded. When the machine is initialized, for some reason it initializes really early, and so you have to do this check because API won't be set right away, and it will absolutely run into this. Okay, so the inventory, I want to do we have input slot inventory of 0. That's tank 1. Where is this? 259. Okay. So input slot, there are 3 inputs to this machine. Okay. With 3 inputs, there is no singular, because one thing that you could do, right? Because I really try with my machines, I really try to make them as flexible as possible in terms of like what they can do. So in the case of like the extremes of the edge is you could take water and break it into hydrogen and oxygen, right? So that's one item input or one fluid input. Or you could take an item input and no fluid inputs and do something with it, right? I don't know what, like, I'm sure there's somebody out there who's got ideas of what they could do and recipes they could add. So I want to be able to accommodate as much flexibility as possible in terms of like inputs with the outputs, right? The outputs are kind of hard coded, right? You have one item and 3 fluid outputs, which that's a crazy number of outputs. Nothing in the base game even comes close. Like the base game, there are no crafts that have more than one output. That's just not possible. So yeah, for me at least, I really try to be accommodating. So input slot, if I comment this out, I think I need this for some sort of interface. Maybe not. Maybe not. Okay. So input slot. if I do input slot 1, how about F1? F2, I1, no, yeah, this is probably, yeah, there's an issue. I don't see any other issues though. Public bool inputs empty. Return input slot f1 dot empty and input slot f2 dot empty. No, come on. Dot empty and input dot empty. This and this and this, right? If this is empty and this is empty and this is empty, then input's empty. Yeah. Okay. So with that, we can come down here and say if not inputs empty. That fixes that, which is nice. So now we go back to find matching recipe. And then we do if inputs empty. Oh yeah, we need let's see. Public recipe chem plant current recipe equals null set state enum dot sleeping public long recipe power applied. Recipe power is 0. Return false. Okay, so if inputs are empty, we want to clear out the current recipe, set the machine itself to sleeping, and set recipe power applied, which this is the meat and potatoes of the machine, right? This tracks how much power has been applied to the recipe, because that's how the recipes work. It's an amount of power that you have to apply to a thing. And that gives you the craft time. You take the power per second of the machine, you take the power applied, and that gives you how much time has to go by in seconds. Okay. So with that, that's the check to see if all of the inputs are empty. Otherwise, we want a list recipe chemical plant C chem recipes equals API dot mod loader dot get mod system of VE recipe registry system, I think. Yes. True dot chemical plant recipes. So this grabs the chemical plant recipes that are loaded. Okay. If chem recipes equals null, or chem recipes dot count is equals 0, return false. Something happened, something bad, return false. For each recipe chem plant, see recipe in chem recipes if m or c recipe dot enabled and c recipe dot matches. There's the matches right here. So this is the actual thing that wants item slot ingredient. Okay. Now we have some work to do. Because there is more than one ingredient. So, do we have a machine the mixer does? If we look at the mixer, input slots. Hey, Merzak, how's it going? So we have input slots and then output slots. And I bet you anywhere these are used for the recipe. Yep. So what we're going to need to do is we're going to need public item slot input slots get. Yeah. Return new item slot. No, I wanted to do this. This is going to be inventory of 0, inventory of 1, inventory of 2 as item slot liquid only, as item slot liquid, come on, item slot liquid only. Okay. So inventory 1 or inventory 0, inventory 1, inventory 2. Those are your items input slots. Public item slot output slots get return new item slot inventory of 3, inventory of 4, inventory of 5, and inventory of 6. And then I need this. And that is how we do that. Okay. So now we have input slots and output slots, and these are mapped to the slot IDs that they need to be, as well as casting to the proper type of slot, because these are definitely liquid onlys. 4, 5, and 6, and 0 and 1, and then 2 and 3 are the only two that are. So 3 is the output item, and 4, 5, and 6 are the output fluids, obviously. Okay, so now we come down to, well, we need to open the recipe, and we need to look at matches. Okay, because this is going to make this much, much, much more complex. Because this matches here. Let's look at the recipe for the mixer and go to matches. Pair input. This is like way less than I thought it was going to be. Do I have a pair input? I do. Input stacks, I do. Basic APIs. Are you talking about the game's APIs? The base game? The best tool that I use for kind of digging into the game and how the game works. And I know everybody's different and everybody's, can learn differently. But what I do is I use DN Spy. So DN Spy, it's a free app, right? But it basically allows you to load the game's DLL files, right? Vintage or VS Survival Mod, Vintage Live, Vintage Story API, right? And so you can load these DLL files in here, and it will bring in everything about it. And so you can in here search, right, for phishing, and it will search everything that you have open, right? All of the DLLs that you have open, which is a lot because I use this app a lot, but most of these are system stuff that other things reference to. But anyway, so you can see, right, item phishing poll right here. So you can double click on this, which pulls the item up, right? Item phishing poll, and then you can see all of this stuff. And then you can say, all right, well, how does this work? And you can look to see all of this, but you can also look to see the other thing you can do with this is you can analyze stuff and see what might use, right? What might use this. So like try merge stacks, on before render, on collected, update pin offset. Well, it's like, well, this is a weird call. Where does this go? You can analyze and say, okay, this is used by these, and this uses all of these, right? So it's just like I've used apps like this to mod so many different games. But the other thing you can do in DN Spy is you can actually debug the game, right? You can, after you've loaded these, debug attached to process. You can load the game, load your world, attach this to the process, and then literally add breakpoints. Right? Add a breakpoint. And once you attach this to the process, your breakpoint can get hit, and you can see, you can actively debug the game. So if variables are doing weird things or something isn't right, you can load this and use this to debug and get like what variables are what. It's beautiful. The only caveat is you can't you can't debug, you can't use Visual Studio. Okay. I can't debug this, like hit F5, right? I can't debug this and load this and debug. You can only have one debugger loaded at a time. But so what you do with this is you just debug start without debugging. Right? You start it normally, but you're not attaching to that process, and that allows you to attach this to the process. And then if this is fine, you can detach this, right? You can detach this from the process and then attach this to the process, and you don't even have to stop your game. You just attach it, and now you're debugging in Visual Studio. It's beautiful. It's absolutely beautiful. So yeah. Debugging has come a long way since when I started in the late 90s. Programming has come a long way since then. But yeah, debugging is wonderful in this setup. And I know there's people out there that use VS Code and all that, and that's fine. I've been more frustrated with the VS Code than anything. So I Visual Studio I've been using for 30 years. So I'm sticking with Visual Studio because I've been using it for so long. Okay, maybe not 30 years. I started using it in like 99. Yeah. Right around 99. 99. 98, 99, somewhere in there. The Lab Goblin is back. Huh. Okay. So the pair input checks all input slots and compares recipe ingredients that match type. Okay. So alrighty. So we go to recipe mixer and we go move to new window. I'm moving these on my other monitor, by the way, so I can actually see them while I, poke at it. Okay. So we're going to go back to this and we're going to go matches. So item slot, boink, ingredients. Now, I don't think we need any of these. Because there's no fanciness with this. Like, we don't have a number of extensions. We don't have a requires. The requires slot was like the metal press requires a certain, like a plate requires the plate mold, right? That's what the requires was. Is like, it's not an ingredient. It's like, it's not consumed. It's a special way of handling it. But with this, what we're gonna do, Cat, you just laid down on my lap, and now, yep, there she goes. I'll never understand ever. So if ingredients dot length equals 0, return false. And then you're bothering me. What's going on, Luce? Should I turn off my air conditioner so you can sleep on the couch? Not really turning on. We've had a really cool, really wet June. like crazy amounts of water. So crazy weather this year. We had a non-winter. I don't know how everybody else fared, but we really didn't have a winter at all. We were hitting like 40, 50 degrees in February, which is insane. Okay. So, here we go. We want barrel recipe ingredient. Pair input. Crafting recipe ingredient. Item slot, crafting recipe ingredient. Now, matches. Trying to find trigger matches recipe. That's new. Some of this code has changed since the last time I've been in here because they've rebuilt the recipe system. Trigger matches recipe. Oh, that's an event. Okay. Matches shapeless. High recipe ingredient. There are actually not that many recipes in the game, believe it or not. They have smithing, knapping, grid, barrel, and I think that's it. Grinding. Sorry, there are grinding. Oh no, those are props. Yeah, actual recipes. There's not that many. Everything else is done through JSON properties. Grinding props, crushing props, combustible props, stuff like that. Those are not out and out recipes. Those are just flat conversions. Free RAM server. Okay. Matches. This stuff matches shapeless. These are not actually recipe base. Woo! Okay. This is a different. Wow. Let's see. Yeah, because I think this, like, pair input, matched input slot. Basically, what I have here is list key value pair of item slot barrel recipe ingredient. I have recipe system. Crafting recipe ingredient. Ingredients. Why is that there? Okay. If matched null, return false. Return true. Okay, so down here, we have satisfies as ingredients. So we are processing into this function. Remember, this is just looking at one single recipe. This is not looking at all of the recipes, just a single instance of a recipe. So when we're looking at it, we pass in to pair input. We say, hey, here are the ingredients, and we're already in a recipe. So we're already in an instance of a recipe. Do these inputs in any order match this recipe? And that's what it's looking at. It's saying, hey, the input ingredients in the JSON, right, in the definition of that recipe, those inputs can be in any order, right? They're not guaranteed to be in the proper order or in the same order. So we have to look at those ingredients as these can be in any order, right? You can have two fluids and an item. You can have a fluid, an item, and a fluid. You could have an item, fluid, fluid. You could have just an item. You could have fluid, fluid, nothing, and then any combination of that. But each recipe is being checked, and it's looking at saying, hey, I have this many inputs, right? And then I have this many ingredients, and this is checking them and saying, hey, we have, we have to check to see if we match. Okay, so here we go. We're just going to kind of skim over this. I don't honestly think match.add. This is returning the key value pair matched. So if matched equals null, which means return null means it wasn't found, then we return false. But if we did find it, then return true. Okay, I think pair input. Yeah, and this was done. This was based on the barrel input, and the barrel input has this because the barrel input has possible two inputs, a fluid and an item. And so this function literally exists because of the barrel recipes. I was using VS. Yeah. I'm old. Yeah. Yeah, I started dipping my toe into coding in right around 94, 95 in basic. I was in junior high. 94, I would have been, no, maybe not junior high. I would have been right going into high school. So like 14, 15. And I hated basic. I hated basic. It wasn't intuitive. It was illogical. The fact you had to number your lines was just like, why do you have to do this? Like, this is stupid. Like, why can't a computer just count my lines? And so, like, why? That was a ridiculous requirement in basic. Line 10 and then thing, and then line 20 and then thing. And you always counted them by 10 because you never knew when you needed like lines in between. But I was always like, why do you have to number your lines? Can't the computer just read it? It was so stupid. Anyway, so I jumped from that to the web. I had my first website in 1995. I had a website. It was very stereotypical website of what a kid would do in 1995. It was completely covered with animated GIFs. There was just so many. So, yeah, every animated GIF I could find, I put it on that. Put it on that. I put it on the website. But I was the first person of anybody that I knew who had their own website at that time. I mean, we're talking early internet. 95? Early. But anyway, I digress. And shortly after that, my brother and I started a company. We founded a company, and I learned Perl, which was the primary web, internet scripting language. I learned Perl as a senior in high school, and that had its own quirks. But then when I went into college, then I started, then I learned the C languages, starting with C++. So then I cut my teeth on C++ and even did some assembler and lots of programming, lots of languages. But then when C# came out and I started using that, I wasn't using it in college. I was using it in my job, and I fell in love with C#. It was so phenomenally intuitive and useful. It's a little on the verbose side, right? It's a little on the verbose side, but it allows really rapid coding. Okay, so we have this ready to go. Okay. And I'm sure there's a lot of optimizations that I could do. It's overwhelming at this point. Satisfies as ingredient. Yeah, individual things, outputs, inputs. This VE recipe variable output. This is my custom class that I had to introduce because base game, for one, did not allow variability in the outputs, right? So if you want a random output and you say, hey, this outputs this outputs 5 of something, but variability is 2, right? So you can go 3 all the way up to 7. But the variability there, that's what I introduced here, as well as the ability to output more than one thing. Because if you look at any recipe, right? If you look at any base game recipe base, let's see, where do they declare all their variables? Attributes requires average, skip variance, recipe output right here. There's 1. Notice this is not an array. This is not a list. This is not anything other than 1. You can see up here, the IEnumerable, iRecipe ingredient, recipe ingredients, recipe output. Right? And if we go to derived types and you say, all right, barrel recipe, how many outputs? Ingredients, output, 1. Barrel item output stack output. It's just the 1. Same with all the other ones, right? So it's like, okay, you can only ever have 1. I, however, do not. So this is why I had to roll my own recipe system, because I can't use the base game's recipe system because it only allows for 1 output. And non-variable outputs. So I had to roll my own. As much as they've improved the recipe system, I still can't use it because they didn't do that. Okay, so try craft, item slot, inputs. Let's do inputs there. And let's see if there is a try craft. Blah. There is, and it's brutal. Okay, so try craft, we're going to do list key value pair item slot, comma, crafting recipe ingredient of matched equals pair input of inputs. If matched equals null, return false. Okay. So this grabs, right, and it matches everything to the item slot and all of that, right? So you can now match the recipe ingredient to the slot that it needs. And this is important because you might have differing amounts of consumption, right? So like a cracking recipe, for example, it might take, let's say, 5 liters of heavy oil, but 10 liters of water. So you have asymmetric consumption. Well, you need to make sure that you're matching those with one another, right? Because it's not guaranteed. Okay, so output slots. I don't know. We'll think about that in a second. Let's see. Because I've started offloading the craft to the recipe, and that way the machine, once the recipe is done, it just sends the craft, it sends the slots, and then when it comes back, the slot should have everything adjusted, right? It should be like, oh, all of my values are adjusted. Okay, so I have a main output. I don't know if I want to. We have 4 possible outputs for this. So this is a crazy possible thing. So if this dot outputs dot length does not equal output slots dot length, return false. That's an important thing to check. The outputs of the recipe that we're in need to be matched to the outputs. Okay, and then we want to do a custom public list key value pair item slot V, what was it? VE recipe variable, VE recipe variable output. And this is pair output. Item slot output. Okay. So list, why don't we just do, instead of retyping that, boink, output, mapped equals new, do that. Okay. So we want what can be simplified. Oh, I don't need that. That's fine. So with this, what I want to do is somehow match the if let's see, the pair um pair output. So we're passing in the item slot, or passing in the slots of the outputs. So now we need to match the item slot to the output. But the slots might not have anything in them. Okay? So the item slot outputs, the slots will exist, but they might be empty. So we can't compare if this equals that, right? So how do we do if we do for int x equals 0, x is less than outputs.length, x plus plus. What? Oh man. My brain is not working right today. So if we take a page from this pair input, we do a Q item slot output slot list equals. What just happened? Oh my god. The IntelliSense has gotten worse. Worse. Because it's not based on things that you type anymore. They've linked it up to some bizarre AI that just like tries to anticipate what you want rather than what you've done. And so it's taken a giant step backwards. And it just like drops in a huge chunk of code. And it's like, no, that's not what I'm doing. Like, what are you doing? That's so stupid. Okay, so then we do for each item slot val in outputs if val.empty output slot list dot in queue val. Okay. This queues output slots that have something in them. Okay. Now we don't need. Let's look at the barrel for a bit. Try craft. Let's see what they do. Input slots. Get output size. Yeah, see, this is, you're not, try craft now. You're not passing in. Okay, so yeah, this, the reason why is the barrel's input slots are also its output slots. Okay. There is no difference between the two. Okay, in value tuple in matched. Where's matched? Matched is pair input. Yeah. This is a very simplistic version of it because there's only one item slot and one fluid slot, right? So if it's liquid, then it's obviously in the fluid slot. If it's not, it's obviously in the other slot. So it's input item slot and then liquid slot. And it's just like very, very simple. So that's not really going to help us. Value tuple. This is the first I've seen this though. Value tuple. How is this different from anything? Like, how is it different from a dictionary? I don't know. So for each output slot, if it's not empty, then in queue. Okay. Now okay. See, it just blawed in a giant thing there, and it was like, okay. Pair output. How do we want to do this? I need to pair the output of the recipe so if we do so we have a queue if output slot list dot count is greater than 0. Else so the two things here is if our output slots actually have stuff in them already or not. Right? If any of them have something in it, then we need to match the slots because the recipe output is going to try to push stuff in there. We need to be able to match the fluid types. Like if one tank, let's say, has, fluid X, and then the recipe tries to craft, we don't want fluid X going into the wrong tank. We want fluid X to go in the same tank. So we want to make sure that the slots are good. Now, if they're all empty, then all that matters is the fluids go in the fluid slots and the items go in the item slot, right? So that's all that matters there. So with this, it should be a little bit easier. Where the item slots for each item slot slot in outputs, if slot is item slot liquid only, else well, how about we do, yeah, instead of looking at the slots, let's look at should we look at the actual outputs of the recipe instead? Recipe variable output. Because if we look at our chemical plant and we look at the outputs, right, the first one in this array is going to be the item. So int f equals 0. Well, 4. We want to do mapped dot add. New key value pair item slot would be outputs of F comma that's the slot, and then outputs oh man, I need to think about this for a second. I'll be right back. So I've now depreciated my Stream Deck and gone to Touch Portal, and it's freaking awesome. Like, it's so flexible and so like programmable and cheap. I bought the Pro version, it was like $15. Lifetime license. $15 for crazy amount of like flexibility and power. And I mean, I bought an icon pack for Farming Sim that was more expensive than Touch Portal itself. So yeah, you know, it is what it is. But I mean, the icons are really cool looking. But it was an icon pack made for the Stream Deck. But I just extracted the icons, and I'm going to use them on my Touch Portal, and it's going to be like, I'm not going to have to use all the damn hotkeys all the time. It's going to take a while to like configure the screen, but you know, that's the kind of shit I love. I love like little programmatic things. Like, do we have Touch Portal? Right? So like Pages, this is my Touch Portal right now. Right? If I hit my webcam, boink. Right? And it's like, this is the button right here. And this button, if I click on it, you can see, right? I have a bunch of actions. Like, this is crazy powerful. Right? On event, webcam hidden, webcam visible. And I don't know what's going on here. We can delete this. I don't know why that's there. So, right, this changes the icon. And you can change so much more with this, right? Text size, color, all of those variables, all of these, you can change, right? I just have text and icon changed, right? So when I hit the button, the actual text on the button changes to icon hidden or webcam hidden, and then the icon changes. And then I hit it again, and boom, it's good to go. And then this is your actual events, right? The actions that are taken. So foreseen, streaming main, the source, webcam, toggle. And then I have two of them because my other scene, when the streaming like full screen, like game capture, I have both of them in here. So I only need one button, and it turns the source, the webcam source, it turns it off and on for both scenes. So I don't have to have multiple buttons for the thing. It's so good. So it's like, it's just absolutely, it's brilliant. It's absolutely brilliant. So highly recommend. Okay, so I think I don't know. I don't know what to do here. I'm in like a catch-22 loop with my brain. Right? Right now I'm kind of going around and around and around in circles in an infinite loop, because it's like I have outputs that are the output slots are going to be all of the slots. Okay? Always. So when I pass in the slots, the outputs are going to be all 4 slots. So the number of output slots will always be greater than or equal to the number of outputs the recipe has. There should never be more outputs for the recipe than there are output slots. So we can do that sanity check. Yeah, we can do that sanity check somewhere.
Where's my try-craft? There it is. Outputs.length. This is wrong. Outputs.length will always be less than or equal to output slots.length. So only if outputs.length is greater than output slots.length. Output slots.length will always be 4. Always. Outputs.length will be variable, right? The machine could output just one thing, right? But it's going to get 4 slots to put that one thing in. I don't know why my brain is hemorrhaging when it comes to this process. Usually I'm fairly adept at this, but this is messing with my brain. So this is the instance. I don't want to for each on the output slots. Okay. F equals 4. That's the first fluid slot ID. But that doesn't matter. That should be 1. That's the first output slot ID of fluids is 1. Output slot ID of 0 for this, right? Outputs of 0 will always be the item. So for each crafting VE recipe variable output in outputs. Okay. For each output, if remember this block of code is only if all of the outputs are completely empty. If output dot matter collect resolved item stack dot collectible dot is liquid. If not, then we want mapped.add new key value pair. This is going to be outputs of 0, comma, output. Else mapped.add new key value pair outputs of F comma output F plus plus. Okay, so if it's not a liquid, which means it's the one item, then it's mapped, hard mapped to the first output slot, which is outputs of 0. If not, if it's a liquid, then it's mapped to outputs of F, which is just whatever order that is in, map the output to that, right? The output here is all of the outputs in this array, right? Outputs is an array, just map it to that. Okay. Now we want to do this Q, the Q is all of the slots, all of the output slots that have something in them. So, how do I want... I need to first... I'm looking at a little block of code from the pair input and seeing kind of how it's structured. To make sure that I'm kind of keeping in mind all the little gubbins that I have to actually pay attention to. Because remember that while output slot list dot count is greater than 0, item slot output slot equals output slot list dot dq. So that pulls a slot off the queue. Okay. Now we want to do if output slot dot item stack dot collectible dot is liquid not right. Then we want to do mapped dot add new, and we want to say this slot output slot actually yeah, this won't work. That won't work. Because it's not, I mean, how do you map it to the outputs? I need to map it to the output. So for int I equals 0, I is less than outputs gradient list dot count. Ingredient list. Where's this at? Ah. Why do I duplicate the outputs? Okay. Bool found equals false. Int num found equals 0. So now this is iterating through the outputs of the recipe. So then I do an if output slot dot item stack dot collectible dot code, well, dot collectible equals outputs of I dot resolved item stack dot collectible. If the output slot that we're checking, right, if the item's in there equals the outputs of the recipe of I, so we kind of have a kind of like a list, two different lists going at the same time. The while loop is going to iterate through all of the slots that have, like, all of the output slots that have something in it. Then we're saying, all right, for every one of those, we want to look at the outputs of the recipe, which is the second loop, which is this inner loop here. All of the outputs of the recipe, if we find a match, right? If there's a match, and I'm really hoping that satisfies as ingredient. I don't know if there is a satisfies. Yeah, there's a satisfies as ingredient, but there's not like a satisfies as an output. But we're checking the collectible. Collectible is the generic version of the item stack. We're not comparing the stack, right? We're not comparing the stacks. We're comparing what's in the stacks, which is the collectible. So if we look at collectible object, okay, this is the base class for literally everything in the game, right? All items, all blocks, probably not entities though. I would guess, yeah, items and blocks. So in here, there should be an operand, like an op something. There's not an equality. Is this not derived from maybe registry object is? No. This is not an I equatable. I mean, is liquid matter state? It's fine. Is reasonably fresh. I love that. Item class. I don't know. Because block, right, and then item, but we don't have I equatable. Usually you would have an I equatable. This block or item ID. I don't know. We'll try it as is. I really I could do like collectible.code equals dot code, right? And then we go back to here and we look at code, wherever it might be. Probably under registry object. That's my guess. Because registry object is the base class of all of the things. There's your .code. So asset location is I equatable. Right? We're comparing the code, which is I-equatable with other codes. So it's like an I-comparable. So this, I think, is a safer compare. Why the collectible doesn't have an override for that just calls the code, I don't know. But we do found. Well, we do num found plus plus, right? We found one. Found equals true. Continue. I mean, I could do a break. Yeah, let's do a break. We found it. We don't need to iterate through anymore, even though it doesn't really save us a whole lot. If not found, return null. So we have an output. I'm just going through the logic in my brain, right? So we send it all the outputs, any outputs that have stuff in them, right? So let's say we're cracking heavy oil and we're cracking it into diesel, whatever. Like, just pick your poison. But we're cracking it and we have X number of outputs, right? We have 5 or 4 total outputs. 3 of those are going to have something in it, let's say. So we iterate through all the outputs. Any of those that already have something in it, we enqueue into that queue. We put it, and a queue is just a queue is first in, first out, as opposed to a stack. So a queue is just you put one in, that's the first one that comes out. Sort of like the queue in a grocery store line, like your checkout queue. The first person to go in is the first person to get served. So bound equals true. So we have all of the things. We have the slots that we're doing, and we're comparing a recipe. We're in a recipe. We're going through all of the outputs that we have, and then we're checking all of the recipe outputs. And this, we want to say mapped.add new key value pair. And then this would be output slot. And then outputs of I. Okay. So we then map that output because we find a slot, right? We find a slot that has something in it that matches one of our outputs. So found equals true. But if we iterate through, if we grab the slot and let's say it's like bitumen, we have bitumen, which is an item output. But then we iterate through all of the output slots of the recipe, but we don't find bitumen. Bitumen is not an output of this recipe. Found will be false. So if not found, return null. Right? We have an item in inventory, right? We have an item in the output slot that does not match an output at all. There's no output that matches. Do we want to return null here? Because, I don't think we want to return null. I think that's a bug waiting to happen. Because we might have a pipe removing items, right? like one of the tanks might be empty, but the other two aren't. So just because we don't find the output does not mean, bad times happen. So I don't know if we need found equals true. I honestly don't. I don't think we need that. Honest to God, I don't think we need that. Num found is definitely something we want. Right? This is a good one to have. I hate that I can't. Why? The one thing Visual Studio doesn't do is trim trailing spaces, and it's the one thing I would really, really love it to do. And no matter how many tutorials I look at, I still can't find it. Like when I do Google searches and stuff, it's like, oh, you just do this and this and this and this, and boom, you just enable trim trailing spaces. But it's like those options don't exist. I have not been able to ever find them. If we go to like tools, options, and we go to say text editor, code cleanup, configure, profile one. There's a lot of them in here, but there's no trim trailing spaces that I was able to find unless they added one recently. Plus, they're not in alphabetical order, which is really annoying. There should be one in here that's trim trailing spaces. Why is that not in here? Right? It's not in there. It's not in here or advanced. It's like, why? Why? I show white space. That's in there. Trim trailing spaces. It's a really basic text editor feature. But for some reason, I mean, I know it would screw up some languages, but this is C#. This is not gonna get messed up. Okay, so we have the pairing here for every output slot. Let's see. The problem is, man, we might have to re-add that found, because if something is not found, we still need to add it. Right? We still have to do something with this output slot. Right? We dequeued it, which means we're going to lose access to it once the while loop comes back in again. So here we go again. Let's do bool found equals false. Found equals true. After this, if not found, unable to match output slot with output with recipe output stack recipe output. I'm going to match an output slot with a recipe output with a recipe output. My U key is acting strange. Not item sling. I've literally never typed that before. Unmatched equals new. If not found, unmatched dot in queue output slot. Right? So this is kind of, I'm sure there's a way to do this more optimally, but I want this while loop to finish. So we're taking every output slot that had something in it. We're trying to match it with a recipe output, right? Whatever order that these are coming in. So outputs of I. Now, if they're not found, I need to re-enqueue those into a list that says, hey, these are not found, right? There's no matching output slot for this item, whatever it might be, right? Because imagine there's a fluid output and there's an item output, and you have a pipe that's pulling the item outputs, but not the fluid outputs. So when the recipe finishes, it has an item that it wants to output and a fluid. Well, there's something in the fluid slot, so we're going to be able to match what output slot matches that fluid. But the item, right, that output is not going to have a slot that matches. So we're going to have to then reprocess any that were not matched to output slots that were not taken, or the item output slot itself. But it's also going to allow us to make sure that if the output is an item and the output slot has a different item, that's a fail, because the slots they don't match. So this process here, while output slots.count greater than 0, we want to dequeue this process, re-enqueue any that are not matched, and then after the while loop comes out, if not found, right? Found equals true. If not found, we want to say, we already set found bool found equals false. Okay, so okay, so now after this while loop, we want to do another one, while unmatched dot count greater than 0. We want to process unmatched outputs to some output slot. Okay, so item slot, again, item sling. Why? Unmatched output item slot I meant this to be an M. God damn. Output equals unmatched dot DQ. DQ. Okay. If let's see. Let's see. Yeah, see, we're processing these slots. We need to process the outputs. right? We need to process those outputs. Because these are outputs that have something in them. No, wait a second. Wait a second. This is. I'm thinking of this. Well, let's see. We have an output. We have a slot, an output slot that has something in it. Right? This is the reason why it's in this queue. But we didn't find it in the outputs of the recipe. I think, yeah, we are. This actually. Because if the output slot is empty, it's not going to be in this list. If the output slot is empty. So only slots that have something in it have a are going to be in this list. So I think we go back to what I was doing before. If not found, return null. Because this is, this is bad. We're going to clear this off just to get us back to here. Yeah, if we have something in an output slot that has no recipe output match, that means somebody needs to empty the machine, because the machine, the chemical plant has stuff in it that don't match whatever recipe this is, right? Whatever, like, let's say it's full of plastic, but this is we put in a bunch of heavy oil and water to crack heavy oil, but that's not the plastic recipe. So we have a bunch of plastic in there. So we have an output slot of plastic. It's got a ton of plastic in it, but the recipe is the heavy oil recipe, which doesn't output plastic. And so the plastic output doesn't match any of the things that the heavy oil cracking recipe puts out. There's no match between those two. So if that's the case, return null. So pair output, we want to do pairs the given output slots with their corresponding, I think that's how you spell corresponding, C-O-R-R or C-O-O-R, corresponding, so they're corresponding recipe output. My U key is just, there it is again. I don't know why do I go through so many keyboards? I even popped the key off the U key to see if there was cat hair in it. There's nothing on it. It's just, keyboards for me only last 2 years. It's crazy. Yeah. Okay. So now we want to do for VE recipe variable output in outputs. What is this? For each. So now we're going to iterate the outputs Okay. So this is kind of like what we have down here. Because any slots that are not matched, right? Well, let me put it this way. This looks at output slots that have stuff in it, right? That's what this does. This actually looks at the outputs of the recipe. Okay, so if mapped dot contains has, oh my god, contains, I just mapped dot I just want to see if this thing has capacity clear contains. Find. I don't find index. All I want to do is iterate through these and say, hey, are there any outputs, any recipe outputs that do not exist, right, at all? So rather than do this, why don't I do just a kind of a cheeky little cheat thing here? List of int matched indexes. Jesus. So outputs of I, this is what I'm matching here. Matched indices dot add of I. Right? So I am matching, I'm iterating through all the outputs. So outputs is an array, so it's 0 to outputs.length. I'm just saying, hey, give me these indices. With this, I could also grab which, I could, instead of just blanketly doing this, I could say, hey, if this is if I is already in here, then we have a problem because we're adding 2 slots. But instead of doing this, outputs, oh Jesus, match indices. So I'm including like 0, 1 or 0, 3, blah, or like I'm matching those output indices. So instead of doing this, we do a for int I equals 0, I is less than outputs.length, I plus plus, if matched indices dot contains I continue. right? So the other thing I could do is flip this and go if not contains. Usually I try to I try not to flip the Boolean logic to say, hey, if false, because it's confusing. Because like not, if we negate it, if not, this means if it's not contained. But the contains is like, hey, I want to know if it contains it. So in my mind, the if statement is like, if it contains it, but if I do a not, then it reverses it if it doesn't contain it. So it's like confusing to me. At least at a glance, I can always figure it out. I'm not idiot, but it's like I always try to be like, hey, if this contains, then I don't have to think about it. So else, if outputs of I dot resolved item stack dot collectible dot is liquid not this one I am going to not it. Okay, and then we want to check outputs. If outputs of 0 dot empty, then we do mapped dot add new key value pair. Item slot would be outputs of 0, comma, outputs of I. Else, now, this outputs of I, if it's not a liquid, and outputs of 0, which is what we pass in, is empty, right? Then add it, map. Basically, this adds that map, right? It maps the outputs of I, which is the recipe output that we're matching, to that outputs of 0. Right, because it's not a liquid, so we're doing that. Otherwise, return null, because outputs of 0 is not empty. Outputs of 0 is not empty. We have an item output, but outputs of 0 is not empty, which means it was checked up here, but it didn't match. Right? The two codes did not match. So an example would be cracking heavy oil maybe outputs bitumen as an item, but the current recipe that's being looked at is making plastic. Right? So the output would be plastic, but there's bitumen in there. So there wasn't a match. There was no match, and the item is a mismatch. There's something in it, but it's not matched. So it should never add I to the match indices, right? And this should have already triggered. So this should have already triggered. It should never get down to here if there's an item output that doesn't match what's in the machine. It should never get to this spot. But just in case, it's always wise to do this. So we want to do an else here. Now, we have outputs of length of I. Matched indices contains I. So this is one of those like this is one of those situations that if the item is a liquid, right? If the output is a liquid, Um, but we haven't matched it. Um, so this is going to match indices, outputs of I. It's going to match the indices of the outputs. So, oh, this is really nasty. I'm sure there's an elegant way to do this. Outputs of I. Oh, my brain is like foggy. It's weird. I'm staring at this code going, I don't know what the hell to do here. This is a really bizarre logical situation. You could have recipe ingredients or outputs in any order. You could have items in the machine at any amounts in any slots. You could have a recipe trying to output items and fluids in any order to try to match in anything. And it's like you have a lot of like really open-ended things here. So this match indices contains of I. So we're literally iterating through outputs.length. Any output of I that's matched, we don't need. Okay. But we do need to try oh my god. How do we match fluids up to 3, 0 to 3 fluids to item slots to output slots? Outputs.length. I think what we need to do, because I am matching an output slot to an outputs of I. This, oh my god, okay. I don't know why I'm having brain freeze today. It's one of those days, I guess. Because this, this F is fluid, like fluid slots start at 1, and then every time you go through, you just add, you add 1. So the first fluid you run into, you add it to 1, and then the second fluid, you add it to 2, and then the third fluid, you add it to 3, and then you're done. But this is a different monster because I I don't know. There's it's like my right on the edge of what I'm thinking is like a really elegant solution, and I can't grab it. It's like I know there's a really elegant solution out there. There's something out there that's like, oh, you just do this, and it's like I can't quite grasp it. So we're iterating through the outputs. If we've already matched it, so outputs would be 0 to 3. Those are the indexes of the outputs. Because there's 4 possible outputs, it's 0 to 3. So if we've already matched any number of that, 0, 1, 2, 3, which means we did it up here. We've already matched a slot to that index. So I think what this would be because outputs of I is not necessarily what we want. Because remember, if all we're doing is outputting a fluid, outputs of I will never be 0. Okay? So this kind of hard-coded 0 here doesn't apply because it's a fluid. So it could be 1, 2, or 3. And if we're not contained, then outputs of 0, this outputs of 0, I should change this. Parameter. Just because outputs and outputs with a capital O are just a little too similar. So parameter outputs. So in a recipe that just outputs fluid, outputs of 0, outputs here of 0 is a fluid. And if we didn't match it, then the contains 0 will be false. But collectible code, outputs.length, outputs of I, output slot would be, it really wouldn't matter. So outputs of 0 would be a fluid, but I would need to map that. Let's say a recipe has 2 fluids. It's trying to output just 2 fluids. One of those fluids happens to have a match, right? There's a slot that has some of that fluid in it because it's not empty yet. So there's a match. So let's say outputs of 1 is matched to an output slot. Because outputs of 1 is a fluid, output slot is a fluid, the fluids match outputs of 1, or I is 1, matches. So match indices of I is added, 1 is added to the match indices. Okay? So the fluid, one of the ingredients is matched. The one that has an ingredient. but there's two fluid outputs, but just one of the slots has something in it. So this matches, right, that. Then it comes down here and says, all right, we're going to iterate through the outputs again. Output and 0 is a fluid, but the contains 0 is false, so it comes in here. So outputs of 0 is not contained, comes in here. It is a liquid, right? So I of 0 does not exist, but the output slot of 0 is an item. Okay, so then we have to do a fluid. So let's say outputs of 1 which is matched already to the item slot. So the item slot is added and the output recipe variable output is added. So now we have a pair for outputs of 1, but outputs of 0 is a fluid. So recipe variable output of 1, outputs of 1 is already done. So outputs of 0, I can't just add 1 to offset it into fluids because the match indices that contains 1 is already there. So I can't map a slot to a index that's already there. So I would have to anyway, I think I need to take a break from this. This is add a pair, add a map of an unused output slot, fluid slot for 1, 2, or 3. Add a mapping of an unused output fluid slot index 1, 2, or 3 to the output of I where I is not in the matched indexes list. I think. We started by doing this. This rabbit hole of the last hour and a half was triggered because of this. If matches current recipe equals C recipe, set state on, return true. Okay. This, right, is important because this is what saves to disk current progress. Also, it syncs to the clients. So any data that you want to sync to clients so the clients can see the variables and what's going on, you want to do in these pairs. Because when the server updates the clients, when it creates a packet, like an update packet to send to the clients for any given block entity, it calls this and it sends a tree attribute, basically a JSON packet, to the clients, which then take it and then process it from tree attributes. But it's also run when saving to disk. So the server runs it when it saves this block entity to disk, whether it's a save pulse for saving or you leave the chunk and everything saves and dumps to disk because the chunk is going to unload, and so it saves everything. And then when you go back, when the server loads the chunk, it calls from tree attributes, initializes everything, and does its thing. But this is called before initialize, so you got to make sure you're not using anything like API calls in here, because, or you have an if API words. If API is not null, then you can manage it, but you want to make sure that you're very, very careful with that with API calls. I think we want to just find matching recipe regardless. So the find matching recipe, right? If a recipe is found, if a recipe is found, it returns true. Okay, it sets the recipe, everything is good. If it's not found, which means there's something wrong with the inputs in the inventory, only then do we reset the power applied. Right? If the inputs are empty, that means there's no recipe. Or if we cannot find a match, then we set the recipe power to 0. But if we find it, we do not set the recipe power. Because remember, this is being triggered on the clients as well. The clients are finding the recipe as well. And so I'm not syncing the actual recipe. I'm syncing the inventory, and then the clients are finding their own way. So I don't want to reset power applied if we find the recipe. Right? This is controlled upon valid recipes. This is controlled by the symtick. This is controlled by the update ticks, where this is if the system is good. If is built and not inputs empty and current recipe equals null, Find matching recipe. Okay. So if we're built, which means we're actually in a built state, we're not an incomplete multi-block. If the inputs are not empty, any of them, right? If there's even one thing in an input, then this is going to check. And then current recipe is null. If the current recipe is null, then we want to find. Otherwise, it's built and it's on. And current recipe is not equal to null. Okay. If recipe power applied is less than current recipe dot power per craft. This is a U long dot machine is crafting and recipe is not done. Recipe is complete. I have to use the bathroom again. All right. Now, we'll figure all this. What this does is fairly straightforward. This, however, I wonder. I'm just curious. Just curious. I know this is probably a bad idea. Let's see. Recipe output has outputs array that matches given outputs with their recipe output. It's like a hit or miss thing. Well, that was fast. Here's a cleaned up, more robust version of pair output methods. Well, let's see. Let's see if it's right. So when using AI, right? So I just kind of threw this into Grok, and I'm just like, all right, let's just see how this thing works. First match filled slots, then assign remaining output slots. Has hash set, fast duplicate checking, proper liquid slot handling, increments a counter starting at 1. Okay, I just want to see, right? Output P outputs equals null, P outputs equals 0, return null. Mapped equals. Oh, never use var. Dear God. Never use var when giving me code. I hate never use var. Ever. That is really bad. Never use var. Hash set. First pass, second pass. Okay, I'm seeing how close my code is to that code. So I'm just going to copy this. And we're going to just compare it in here because then it would be easier to do this. Pair outputs. Okay, so they do a little sanity check here. That's fine. Sanity checks are fine. We can just simplify this to that. I'm okay with this version. I'm not okay with var this equals, right, new whatever. This tells me right away what this object is. New, this is just shorthand. But I need to know exactly what this object is as I look down here, right? So the same thing can be done here. This is another shorthand that you can do. It looks like there's even a crazier way. Yeah, I don't know. It's not an index. It's not an array. First pass, so outputs.length if slot.empty first pass match already filled output slots to recipe outputs by code. Output slot equals outputs of S. Okay. I guess, okay. This is just, it skipped the queue. Slots.empty, continue. Bool found equals false. For outputs.length contains outputs.length. This then it's used down here. Okay. So slot code is outputs of I code mapped, blah, blah, blah. There you go. And add found equals true. If not found, return null. Filled slot that doesn't match any recipe output, invalid. It's as AI tools are going, it's amazing that it understands. Like, think about the logic here for a second. Think about what it has to figure out what is going on in this code, right? Filled slot that doesn't match any recipe output is invalid. The fact that it knows, right, that this is the context of, hey, if we're not found, then bad stuff happens. And then second pass, the fact that it logically can figure this out is amazing to me because, yeah, it's not it's not really intuitive. Like, you have to know how to code, obviously, but the fact that it's a pretty amazing logical system. Okay, so I think, yeah, we're just gonna go with this and just YOLO it. Because I want to know, like, I just want to know if this is actually good to go. You be hopping. Yeah, we're just getting everything sorted out here. So pairs output slots to their respective recipe, RECIPE output. If slots are empty, match match unused, match unmapped output. Okay. So let's see. Collectible code, blah blah blah, and then we just want to see, is liquid, boom, solid goes in output slot 0, liquid slot index good, target slot. Not enough liquid slots available. Shouldn't this... Okay, I think I might have found a logical fallacy here. Liquid slot index of 1. There might be a logical problem in pass 2. In the second pass, where liquid slot index isn't incremented if the matched recipe indices contains it already. So again, it's not perfect. This is why you need somebody who knows how to code to review the code, because the problem is you're setting the liquid slot index to 1. Fine. But if this contains 1 and it continues, you're not incrementing it. So second pass, assign the remaining number of slots. Start looking for liquid slots from index 1. So what did it change? Okay. It changed quite a bit of code in here. Yeah, somewhere in here. So this is the problem right here, right? Liquid slot index, this might be where it's at. I think this is the same. This is the same. But this else is very different. Yeah. This else is boom. Okay. Why did it change this variable? Used output slot. Wow, it really used a bunch of these. Aha, okay. There were a bunch more changes than I saw. And we can clear that. Of S. Excuse me? Oh, S right there. Okay. Used output slot indices, right? Is S up here. So down here, it's doing a bunch of checks to make sure it's only adding. Okay. It's very confusing. This is why I was like, I really don't want to do this. I really didn't want to do this on my own. So we have this 4 outputs.length. 4 outputs.length. Well, that's first pass. Okay, we're down here second pass. I can't forget to look at everything here. Okay, item slot is liquid. There is some more code in here. Right here. And then map.add, target slot recipe out, return mapped. Okay. Okay, so we're just going to kind of, cross our fingers and hope for the best. Now, we need, that is distillation, this here. We want to try craft. Okay, so outputs.length is less than output slots or greater than output slots length. This should never ever happen, right? Because if you add more outputs than the machine itself can handle, that's a problem. That's a big problem. So outputs.length greater than 1. Now we want if this outputs.length is greater than outputs.length, or do I want to do a sanity check? Do I need to do a sanity check? Outputs.length greater than 1. Okay, so key value pair of item slot VE recipe variable output paired equals pair outputs of output slots. This should cannot convert 2 key value pair item slot key value pair oh, it's a list. Derp. There we go. So that pairs all of the outputs, okay, to the slots. So that is like the recipe, right? The variable output of the recipe matched to the slot, which is kind of important, okay? So then we do a for each item slot out P. Oh no, we do for each key value pair item slot VE recipe variable output key V pair in paired. Okay. If kv pair dot value dot consume dot wait. Oh, we need to pair input. Paired out. List key value pair of item slot crafting recipe ingredient pair in equals pair inputs. So pair in, we are going to pair the inputs. Okay. Oh. So we want to do for each key value pair item slot crafting recipe ingredient kv pair in pair in if kv pair in dot value dot consume recipe ingredient should be consumed quantity. Why is this consume quantity? Barrel consume quantity. Do I not have barrel recipe ingredient? I think I just have that quantity. Consume. Yeah, because that's specifically like quantity of the item stack required for the recipe. There's a difference between crafting recipe, right? And like a barrel recipe has the consumed quantity. because a barrel recipe ingredient, if we look at the actual recipe, programming, vintage engineering, mod, vintage, recipes, chem plant. Let's look at cracking. Okay. So this is saying, hey, this is a leader's thing. Now, yeah, we might have to change. This is barrel recipe. Ooh, okay. Well, I've already got that. Let's see. I just want to make sure. Everything else, barrel recipe ingredient, that's right. It's kind of funny that I completely forgot that I did that. Recipe chem plant, recipe barrel, I already did that. What do you support? I have no skin in that game. I really have no, I don't even know. I just, kicking a ball on the field, like, go for it. Great exercise. And there are some truly astounding players. There's a lot of great skilled players out there. It's never been a thing for me. So most sports are just like, it's just the modern day gladiator games. That's why they exist. We don't send lions after Christians anymore in the Coliseum. We send, the Cowboys versus the Giants in a giant stadium. That's just what we do these days. But it is what it is. Okay, so pair in. No, what is this? paired out. No, return false. Okay. That's good. Okay, paired out. Okay, so now we have everything kind of converted over to the barrel recipe. The reason why is barrel recipes are built in. Where would it be? Barrel recipe, right? So barrel recipe has in it already built-in code that kind of consumes barrel recipe ingredient. There it is. So from bytes, consume liters, right? So you see there's built-in stuff in here that will resolve the liquid properties. So consume quantity or consume liters is a thing, and then liters here. So resolve, it's built in, right? Base.resolve, this.resolve liquid properties, which is here, which tries to build your liquid properties, because if you specify the recipe as, hey, this needs to consume 5 liters. Well, that's not actually how the game stores liters, right? The game stores fluid in portions. So heavy oil portion, liters 5, that would actually be 500 portions, because most fluids, it's 100 portions per liter. So you have to grab the portion, check the liters, right? And say, hey, grab the props, right? The fluid properties of this. What are the items per liter multiplied by the liters? And that gives you the actual stack size that you need to consume, right? Not liters. The item slot is number of portions, right? Hundreds of thousands in large item stacks. So liters and portions, it's like the difference between a bucket and a millibucket, right? It's like that, where you can the portions you're able to take, 1/100th of a liter in any given portion, but the recipes are actually in liters. So you could specify 0.001. Remember, there's 100 liters or 100 portions per liter, right? So actually it would be like this. This is 100th. This is 1/100th of a liter, which is one portion. So you just multiply this by the portions per liter, and you would come up with 501, right? You just multiply the 100 times the 5.01, and you'd come up with 501. And that's how many portions it would take. Kind of a weird way of doing it, but it is how it is done. Okay, so now we have this. Let's do the thing. Let's go down to TriCraft. There it is. And but to reference, I'm just looking at my mixer recipe. Okay. So we've done the sanity checks. We're not really able to match that. Right? We're not really looking at secondary outputs and stuff. That's what the pair outputs is for. That's what that shorthand was for. So now with the pair in, if kv pair in dot value dot consume quantity does not equal null, val dot I forgot, kv pair in, Jesus Christ, kv pair in dot key, right, dot take out kv pair in dot value dot consume quantity dot value. Else kv pair in dot key dot take out kv pair in dot value dot quantity. Right? So consume quantity, favor that one, which means it's a fluid. If it's not, then consume quantity won't be set, and it'll just be quantity. Okay? So this function actually is the thing that consumes the items from the inputs, right? This is a thing that goes through and it takes out items from the inputs. Then this is the call, right? The paired out, this is the call that we iterate through that actually produces, we map the variable outputs to the slots that they go in, right? So with this, we want to do a very similar thing, but we need to check if kv pair dot key dot empty and then else. It is possible for the item slot, which is the key, so key value, this is the key, this is the value. If the key is empty, which is it's an empty item slot, right? We need to set kv pair dot key dot item stack equals kv pair dot value dot resolved item stack dot clone. So if it's empty, then just put in what the resolved item stack is of the output, right? Because this is the output. The value is the value here. Key value. So this value is the output that's mapped to the item slot. So that's why this function was so important, because it's the thing that maps. We have 4 possible outputs. This is the thing that maps everything. If the key is not empty, if the slot is not empty, then we want to kv pair dot key dot I don't want to can take. Is there just a try put into? No. Key dot item stack dot stack size plus equals kv pair dot value dot stack size quantity. Yeah, stack size. So this is remember, this is mapped. This is mapped. So the item slot, the stack size in there will be just increased with what the paired, what it's paired with. right? So it should just like, if there's 20 in there and the craft is to 5, it just adds the 5 to the 20 and it just raises it up, right? So this we want to do kv pair in dot key dot mark dirty. Kv pair dot key dot mark dirty. You have to mark these dirty, the slots. You have to mark the slots dirty, so they get sent back to the client. Right? This is the thing that syncs it with the client. I don't know if it's 100% needed though. I'm hesitant. But it should only trigger, right, when we don't need this anymore. Boink. It shouldn't trigger other than when this thing crafts. Return true. Now, there could be bugs, there could be edge cases, there could be a lot of weird, quirky things that this isn't doing or doesn't know how to do or whatever. Like there's a myriad of things that could be wrong with this, but I usually don't hit those until I actually start testing the thing. Okay, there's a couple other little teeny things that I need to do. Somebody gave me some feedback here on the handbook for the derrick. Tap into this with an oil pump jack using an oil or using a derrick to place steel pipe to place pipe casing down from the surface. These are actually done now. Those are actually done now. Using not and derrick, let's do proper English. We want to encourage proper English. A crude oil source block. Tap into this with an oil pump jack. Using a derrick to place pipe casing down from the surface. Okay, let's go down to here. Pipe. Okay. Pump jack. The pump jack is a multi-block and should be built so the head, light engineering block, is directly over the well casing block leading to the well, which were placed by the derrick. Okay, so it shows you that the light engineering block, specifically of the pump jack, there's only one of them. That is what you place over the top of the well. Right? So you have to orient the core back 2 blocks from the well. It's just, get used to it. Like, once you adapt and know how to do it, you don't need, it's not going to change. So the derrick is a giant multi-block, is a giant structure multi-block that requires well casing supplied to it to finalize and make ready the well, the pump jack to access or supply well casing to this while extracting to this. Finds the pumps out of the deposit. Build directly centered over the center of the geyser. The center of the oil geyser. I wish I could add like little screenshots to the handbook. Wouldn't that be nice to be able to just include a little screenshot into the handbook? But yeah, for some reason the handbook is just not as flexible. Build directly centered over the center of the oil geyser. Once built, right click with a wrench. Once built and validated, drop its inventory in case you loaded the wrong block for well using. Hint. Once built, right click with a wrench, the same side you used to validate it, to drop its inventory. You loaded the wrong block for well. Yeah, you can right click with a wrench from that side and it will dump its inventory. And then the blocks are color coded, and that's fine. Use ASCII paint. That would be crazy. ASCII painting. Takes up to 1 item and 2 fluid inputs, outputs up to 1 item and 3 fluids. Inputs determine recipe. Multi-block building blocks are color-coded. Yeah. I know I've got probably 1 or 2 in here that are wrong. It's just so hard, like editing handbook entry. Like, look at how long that line is, right? 1,100 columns, 1,100 characters. I have a tough time editing these just because it's like really hard to maintain. So usually, what I do temporarily is I carriage return these so they're actually readable. Because yeah, trying to sort it all out on one line is nigh impossible. Okay, so this then we have machine is crafting and recipe is not done. So now we want Yulong tick power equals electric dot max power per second times delta time dot Yulong. No, don't just assume shit. Stop assuming stuff. If is built and inputs empty and current recipe equals null. If is built and it's on and current recipe equals null. If electric dot current power is less than tick power, return. Current power is less than tick power. Tick power is what the power per second is times the delta time, right? Which is a fractional number, 0.102, whatever, 0.104, 0. Whatever. Right. So this is like, yeah. If electric.current power is less than tick power, which means we don't have enough power for this tick, return. Right? Try again in 1/10 of a second. It's still on. I'm not going to turn it off, but we don't have enough power. We're trickling power in. So you got to return until Until such a time current power is greater than or equal to tick power, then you can go. Because once that's done, then we can say recipe power applied plus equals tick power, electric dot electric power minus equals tick power. Okay. So recipe power applied, we take the tick power, we apply it to the recipe, then we reduce our power by that amount. Okay. When recipe is complete, all sorts of things and stuff happen. Basically, what we need to do is, and there's still a couple little things that we're gonna have to do. So, what we need to do here, we've already got tick power. Recipe is complete. Now we want current recipe dot try craft. We pass it the API just in case. Input slots, output slots. And this is, we want to put an if on this. So if we go back to the recipe here, try craft. Nope, it's up here a little ways. There it is. Return true. Return false. Okay. So current recipe, try craft. Do we need to detect this? Yeah, electric dot electric power minus equals tick power. Recipe power applied equals 0. Find matching recipe. API.logger.error. Chemical plant, try craft, recipe, returned false. Current recipe dot code. So this, if you look at a log file, and of course I close the damn file, Jesus, it'll return this, right? So if the heavy oil recipe returns false, then it will be like cracking heavy oil is the code, right, of the recipe, for some reason it returned false. Right, which is something to look at, but it should spit that out in the error. So yeah, this would absolutely spam the shit out of your log file, though. So, I mean, it would literally every 10 times a second, it would dump that in there. So we want to do if client update delay is greater than or equal to 0.5 F. Right? Because I add client update delay up here, right? And then down here, I'm saying, hey, if it's greater than or equal to 0.5, then reset it, mark dirty. But I'm also checking, this is also run on the server, right? This is actually run on the server. Client update delay is run on the server. This is not going to run on any clients at all. This is only server side. So API.logger here would only write in the server, like maybe server debug or server log file. Then it should only, instead of writing 10 times a second, it would only write twice a second, right? So it's much less, but it's still too many, but this is what we have. I could introduce yet another like log file bouncer and make that like every 2 seconds. But once this gets stuck on a recipe, right? If this gets stuck on a recipe, something really bad happened. Something happened with the recipe. And this recipe is invalid because this plastic pellet is not done. It's not in yet. So that's why you would see, 2 recipes loaded, 1 recipe, was not able to be resolved or whatever the error is, because it's not a valid item yet. You're not able to craft it. So we can pounce that out here. So let's see if we can rebuild. Look at that. 0 arrows, 0 warnings. Great. That doesn't mean there's not bugs. It just means we don't have any errors or warnings, which is nice. Okay. So find matching recipe should be good to go. Current recipe. Okay, and then let's look at block info. Would be what is that? String input fluid. So this shows you, this will on the HUD, this will show you your input fluids. It'll show you percent, it'll show you power. If current recipe does not equal null. DSC.append line. Append line. Do I have just crafting? Just the word. I do. Crafting colon okay, and then I need recipe progress is a very specific public float recipe progress get if current recipe does not equal null, else return 0. Return recipe power applied divided by float current recipe dot power per craft. Yeah. Hopefully this returns what I need. And then get, so this percent power is recipe progress times 100. Dot int. I don't need this on there. And then so these brackets here, this is actually what I have an icon helper here. I have a little helper class This is what prints out that much nicer kind of progress bar on the HUD. And, you can add like how many steps you go. Like, I just default to 10, but you can, I can make that 20. It just makes the bar wider because every one is a character, right? So it's, the math is done behind the scenes. So it's going to be a bar and then percent, but we might want to actually maybe print out like what we're crafting, but it's not 100% like, yeah, I think if we leave that off, because it's not a craft of one thing. You could have 4 different outputs. Which one of those, right? Which one of those are you crafting? Now I could map the code of the recipe to a string and say, hey, grab this code and then map it to a string in here. Could do that. It would be a fancy way of doing that because then I could just say heavy oil cracking and then a percent, right? Otherwise, like if you just say outputs of 0, it's just going to say a crafting bitumen. Well, that's not what it's doing, right? So if we say cracking heavy oil, cracking dash lubricant, or plastic pellet, how about we just do chem plant dash plastic pellet? And then in here, we come down. Again, I really wish you could put comments in these. Vent engineering. We come in here and we go cracking heavy oil. Okay. Let's just paste. Cracking lubricant. I don't even know if you can crack lubricant, but we're going to run with it. And then chem plant plastic pellet. Here. Heavy oil cracking. How about cracking heavy oil? Cracking lubricant. Crafting plastic. Right? So then we go in here. Oh, wrong window. Here. And I'm going to remove this. Crafting. And then we do lang.get vent engineering colon. I actually want to do that. This is going to be crazy. It's going to be freaking crazy. Vent engineering. And then we're going to augment current recipe dot code. I don't really know if you can nest the string interpolation. Like, we're nesting it though, damn it. We're going to try it. So the $ quotes is really a short, I love it. It's a shorthand way of being able to inject code into the string itself, right? So the curly brackets are indicate, like, tell the compiler, hey, this is actually code that you need to execute to get the string that goes there, right? And then so again, I don't know if I can nest this. It's not giving me an error, which is astounding. If it does error out, I could just I could just basically I could take this and grab it up here in a separate string and just pass it into the Git. Okay. Now we want to look at, I don't think we have a custom block. Blocks. So what type of block? BBMB core. Electric block. Wired block. Block. But I should have code on here. Yeah, on block interact start. Fluid interaction. Hotbar. Source. To push. So this here liquid interface, MB core as liquid interface, which I know it is. Get liquid auto push into slot. Okay, let's go to the chemical plant. Okay. Block facing equals null. So this is saying counterclockwise, block facing. So that would be, if you're looking north, that would be the west. That's inventory 0. Block variant of side, which is north, the north face. So we're facing north, but the north face is the face that's basically on the other side of the machine. That's inventory. Okay. So the interaction here is predicated on which face of the multi-block you're looking at. Okay. I was just looking to see if I can maybe test this by putting a bucket of heavy oil in and then a bucket of water. because this should allow me to do that. I'm going to need some quicklime. I'm going to need like 2 quicklime, but this should be a test. I just want to test this thing. So build, rebuild. Okay, and I also want to validate. Well, let's close this and close this. Close this. I just want to make sure I don't have my mod or this mod. Mods. There it is. I do not. I have a couple of test mods in here. Vintage railroading, power suit. I don't think I need these anymore, or at least I don't have any updated versions, so I'm gonna just delete those just in case, and I'll probably get, yeah, it's probably gonna bark a bunch of errors at me saying, hey, these things don't exist. Server bad. Excuse me? Man. I gotta actually look up my password because I have pages of passwords. Good Lord, how far back? Okay. Okay. Because, we can't have nice things anymore. Yeah, this one could not be resolved. That's the plastic. That's why that's happening. So if you see that, it's because the plastic pellets aren't done yet. All right. So, there it is. Right? So, this could be very bad. Yeah, this power suit, I need to build a trash can. Well, let's grab a bucket. I know I have a bucket. Did I put the bucket somewhere? There it is. So grab this heavy oil, this water, and do I have another chest? I do not. Do I have a chest around here anywhere? I do not. Did these run out of power? Oh, it's full. That's why. Chest. Give block. Chest east. Item item pipe. Give item quick line. Now, boom. Crafting, cracking heavy oil. Right? Because the item went in there, the item slot was updated, the find matching recipe was updated and run, and boom, it found that recipe. So it literally worked. Now, if you want, right, to drop all those items, right, to drop the things that are in there. Now, it's going to waste the fluids. You're not going to get those back, but you should be able, right, to right-click where you interact with it to empty those out, right? So it drops them out. Now, where it put them, I do not know, but they're in there somewhere. Now, yeah, this is not really a block, but it is what it is. You know, you just gotta suspend your disbelief once in a while, right? So it did detect that, and it's all good. So that worked. I'm actually kind of impressed that worked. These should be relatively quiet. Did we run out of oil to... No. Oh, yeah. No? There should be plenty of oil. Why is this not... Oh. I disconnected the power. That's... I'm like, why is this not running? It's the power. The power is not running. The power. You don't know the power of the fluid generators. But yeah, there's the item charger now gives you a little bit more information on the screen. When the item is charging, it actually gives you like the charge of the item, so it should be a little bit easier to use now. As I was testing iron or metal sheets because I needed to make sheet metal, right? So sheet metal is made from iron sheets. Makes sense, right? And then what we can do is to try to test the block highlighting thing. Let's do... Where's my world eater? You gotta have my world eater. Very dangerous tool. Okay. So, we're going to face west this time. So place this down and then right click this. So you can see it's a mess of colors. Yeah, it's kind of crazy. I admit it's a little crazy, but right now it's the best we got, right? So the brown, the reddish brown there is these things. So are there any colors here, right, that we don't let's look up chemical plant. We have dark purple. I don't think we have, maybe that's probably it there. Light gray. Well, we don't have any steel blocks. Red. Black we don't have yet. Pink is light engineering, which we don't have yet. Yellow, we have 2 of those, actually 3 of those. Lime green is power. That should not be power. What is that block? That is that's item IO. That's what that is. Okay. Gurgles. Stomach gurgles. Yeah, I think this. I'm pretty sure that is the light engineering. And the cyan here is concrete. And then the white, this bright white back here, that's the ladder. I need to move this to a different monitor. We're going to open this. Okay. Now, look at this here. Fence. Steel fence is black. Okay, and I need to move this to a different monitor. Oh, Lord. Okay. So steel fence. Black is actually fence. I know I have some fence on the derrick. Black. Steel fence. Okay. I'm going to try to do these in order. Black. Platform. Again. We go to the derrick. And I should just do this. This would be so much easier. Okay. So, platform would be mid-gray. Okay. And ladder is white. I wish I could do like a color swatch instead of just the name of it. Just do a little square of what the color is, but I don't know of a way to do that right now. Not offhand. Okay, so heavy engineering is dark purple. Multi-block component steel, we don't need that because we don't have any blocks. Concrete is cyan. Now I don't know where I might have that. Do we have any in the distillation tower? I don't think we do, but let's look. Component. Light engineering. Power. Where do I use that? So I don't use it in, well, that's the fluid generator. I'm looking at the wrong thing. Distillation. Wanted to look at the derrick. Black. Steel ladder. Dark purple. Cyan. There it is. Okay. Light engineering is pink. Yellow is fluid. Wooden slabs. I'm pretty sure the derrick has those. Yeah, the this multi-block has like all of the things in it. Like all of the different kind of blocks. It's the top of the MB power process thing stuff. Okay. Wood slab is orange. Power is lime. I think. Yeah. Power is lime. Interaction is red. Let me move this down. I'm just doing them in the order that I have them in here, just so I don't. And then item IO is green. Okay, what do I have that has an item IO on it? That actually has the label. Distillation doesn't have. Oh no. Oh no. Distillation does have item IO. Yeah. Where's my item IO there, sir? Yeah, the distillation. Oh, distillation base has the item IO. Slab down, power, interaction, item IO. Nope, wrong one. Okay. Black, mid-gray, white, dark purple. heavy engineering. It is 54,691. I'm looking at it. That might be more blue than purple, but whatever. Yeah, this thing literally is like every one of these. Black, mid-gray. Ladder is white. I'm gonna say white instead of light gray. Dark purple. Cyan is the concrete. Pink is light engineering. Fluid is yellow. Orange is the wooden slab. I mean, it's brown, but brown is orange. It's just a dark orange is brown. So lime green is treated wood. No, is the power IO. And then red. What is lime? Let's see. Power IO. Difference between green item IO and power is not a lot. The difference is not a lot. So I might want to drop maybe to like, which one is just plain green? Item IO. So let's do 180. Lime, I want the item IO to be, noticeably different in their green hue to the item IO versus power IO. Because right now I'm looking at the other window here, and my item IO is looking like a lime green. So I need to tone that way down. Okay, so with all of this, let's reset these. And then these are going to be a pain in the ass. Save it. Okay. Save and leave. I know I could reload it, but I'm going to not do that. Move this back over so I can see. So yeah, I toned down the item IO. Down. I toned the green intensity down. And then the power IO, right? The green intensity is way up. So we can make this one, because yeah, power IO is supposed to be lime. So this is going to be like 230. There's a little bit darker than it was. That's pink. I mean, it's purple, but whatever. If somebody wants to give me, my sister is the current expert on pink. Give me RGB values for what pink should look like. what would be a good pink? All right, so this is basically like what the recipe is, right? This is the quote unquote, when I say recipe, so like fluids, this would be here, here, and here. So then if we mark this, you can see, hey, those are right. Right? And if we want to see the ladder, we can put the ladder here. Check it again. Boom. Ladder is valid. Now, do I have any concrete on me? I do. So there. Oh, these still don't have a sound. I really should add a sound to these. And then treated wood planks. I might have these ready to go. And these don't matter what orientation you put them in. So if you do like this, or this, or this, and then validate it again, boink. Right? So it sees those as valid even though they're technically different blocks. Okay, so now we want that gone, and we want to say heavy engineering, I think, is there. Let's validate. Yep, that's valid. Interaction block is red. It's always red. Right? And then we can... Those are fluids. Where's my item IO? They look like... there and there. So now with the interaction there, instead of interacting with that, you should be able to interact with this. Just that this is now, this is uncovered. Most of my other multi-blocks, the core is uncovered. So the thing there, if you're having trouble figuring that out, that is going to be the light engineering blocks, which I have in here somewhere. At least I think I do. Maybe not. Give block. Who needs to craft them when I can just give them to myself? Okay, so then, boom. Now, look at that. We have more things and stuff. So the black, if we now look at chemical plant, there's all the things, right? Steel fence, platform. So all of these are now good to go. And then that is a brighter green, and hopefully people see that right as where to place the power. Now, you can do trial and error, right? If you place the wrong block there, when you go to validate, right, it's not going to validate, right? So let's, for example, this here, if I place dirt right there and I right click it, it's not, the highlight doesn't go away, right? So it's like, the reason is it's the wrong block. So if the highlight stays, the wrong block is there, and you need to use whatever other block you think it might be. So with all of those concrete there now, boom. Now we've got all of that set up. Now, how much fence do I have on me? I got a little bit. And again, with the fence, these are different blocks, right? Because they're connected in different ways. But I have code in there that it doesn't matter what those blocks are, they should be validated, right? Because it's like, hey, all I care about is the actual type of block there, not all of its different orientations and connections. The shear amount. of fence on this build is truly remarkable. Okay, so this dark purple, that is most likely heavy engineering blocks. Right there. And there. And there. That, I think, is a light engineering. And light engineering. Light engineering. And another ladder. And that should validate to the next tier. I really need to add a sound to this I don't know why the concrete doesn't have a sound effect, but you know what, whatever. And then a ladder. And then a validation. Wink. And then, yeah, I need more of those. Blink. And there we go. Blue, now if we look at chemical plant, blue is not in here. Okay. So now that's a problem. This is why I'm doing this, because I knew that I had one that was missing. Okay, so if we go all the way to the end here, this is the chemical plant. And we go blue. And then this would be sheet metal. VE sheet metal dash iron. Oh, I hate when I do that. VE metal dash iron. There we go. That should now be included. And then we need to actually have some sheet metal. There it is. We have another ladder. And then these are black. These are fences. Okay. Validate. Oh, look at that. We missed that. So let's go. Boink. Right? The reason why there's ladders, right? If you're doing this in survival and you're trying to build this, you have to go, you know, up here. And then you have to place all of this stuff. Now, once you build this a couple times and you sort of memorize the recipe, then it's, you know, really easy and straightforward. Right? You build something enough times and you're just going to understand what goes where. Okay. But now you have to interact again. Unfortunately, there's just no easy way to do this. And so that validates to the next one. So you can see there's a whole bunch of fence on this row. So doing that over and over and over again gets you this structure eventually. Right? So this is the metal platform top. And of course, I am dying of hunger because reasons. So this is the recipe. This is basically the schematic that you would build. And then once it's done, it validates into this. This is the finished. Ooh, thunder. Lightning storm in the world. That's crazy. So yeah, this thing is the finished product. And the ladder does work. It's a little bit janky, but it does work. Because the dummy block that gets swapped is climbable. So it's just a climbable dummy block. None of the other ones are climbable, right? This is technically a dummy block sitting there. Just a blank, empty block with a collision box. You gotta be careful, but kind of ensures that wherever you place this thing, you're not going to want to move it. So be very sure of where you place it, because you're not going to want to have to tear all this down and move it over a block if you place it wrong. It's very, very, tough to move. Let's put it that way. So yeah, you get this far and you're like, oh man, I have to move it over a block. Tear it down now, because yeah, doing it after it's all built, because yeah, it's a big machine. But now we need to chemical plant. We need a recipe for this thing. Chemical plant core. Chemical plant. Why is this, when I'm looking at it, it should be giving me this. I don't know. That is a minor issue. So the recipe to make this core let's just copy the Derek here. Multi-block chemical plant, chem plant core. Okay. We have F. What is F? Steel fence. No, I don't want fence. I want VE sheet metal dash iron. So screws in the corners. Top middle is pipe, 6 pipe. each side in the middle is sheet metal, machinery block in the middle. The bottom would be, I just want to make sure my recipes aren't conflicting with other recipes. Like it's because it's kind of hard. Distillation. Let me look at these. Pipe new. That's pipe. That's 3 pipes. Sheet metal on the bottom. Okay. Pipe H. Sheet metal. So yeah, T. We need to change T. Otherwise, this recipe is essentially the same as the distillation base. So what else could we do? How about the bottom would be the fence. Instead of T being this, you make it fence. And you say, you better have eight steel fence. And I know people are going to be like, oh my God, that's so expensive. Yeah, it's expensive. And then this is going to be VEMB Chem Plant. But I think that might be chemical plant. Let's validate. Let's verify block types, multi-block, VEMB chemical plant. So that tells me it's chemical plant. And that gives you the incomplete North chemical plant. It's the default block. So that is the recipe to craft the core. It's really heavy. I mean, it's a beast of a recipe. But that's nothing compared to the material it takes to build it. If you are having trouble crafting the core of this, there's no chance that you're going to craft the actual structure. You need hundreds of iron. And steel, like hundreds of it. So get to mining, everybody, to be able to craft this thing and build it. It's crazy how big this thing is. Okay, so, and I'm sure if one of my recipes is off with this, then I'll probably hear about it, but that's fine. Yeah, it's a big machine, everybody. Look at how that's schematic. Oh man, oh. Amazing. And 15,000 power per second is it's a heavy price, but it's top tier. You should be able to at least produce that, if not all at once, then in bursts. Because remember that the crafting process, it will skip if there's a valid recipe. It'll skip it until there's enough power, and then it'll progress the rest. It'll progress. Then it'll skip, progress. So you're not going to go backwards and lose crafting progress. It's just going to take a while, right? Your power per second, if you're not feeding it the full power per second rating, then the recipe is just going to take longer. That's just how it works. That's sort of the flexibility of the recipes. Is it's not one or nothing. It's kind of a combination. And then plastic pellets, like I don't know. Item types, parts, plastic pellet. I haven't done any of the I haven't done any of the plastic stuff yet. Plastic pellet. So if we look at plastic pellet. Combustible props. It's not going to be a combustible. Shape. Well, let's see if there are any shapes in the base game that we could possibly use. Shapes, item, resource. Utility. No. Mortar. Mortar would work. I think. At least to start. Item, resource, mortar. Ah, come on. Mortar. Dirt. Item, resource, yeah. Shapes, it already looks in shape, right? So it already looks in shapes for shapes. Item, resource, mortar. Now, I don't know if the transforms. Let's look at the transforms. Since it's the same shape, what you do is you look at the actual item. Resource, mortar. Right? And you just grab this. And unfortunately, they don't form their. So 1.9 ground transform, GUI transform, texture, block wood barrel mortar. Got to specify the domain. Okay, and then basically do this. Do I have storage flags? I don't know why those exist. Okay. Now, ground storable. Behaviors. Okay, ground storage transform. I don't think we need that anymore. Max stack size. I'm going to set max stack size to like 200. Just because I'm nice. And they're light. Whatever. Layout, messy 12. Behaviors. Okay. Ground storable. So I want to grab that whole thing, which is this. And then what is my mouse? I think I need to clean my mouse out again. So for the time being, it'll look and function and appear exactly like Mortar until such a time that it doesn't. But at least this will remove the error from the recipe. So it should now see plastic pellet as a valid item. Which is just a little like Mortar. Like it's just a little pile of, it just looks like a little pile of something. It doesn't look like much. Because when the factories make plastic, the raw plastic, it's in little tiny beads, tiny little pellets. We're not going to do little itty bitty things because it would be impossible to find if you drop them on the ground. So it has to be something that's substantial enough to be able to see it. But now, big question for me is always, are dyes in the game? So if I want like colored plastic, right? How do I do that? The dye system in the game, I'm not 100% sure on. Is there liquid dye? Blue, red, yellow, purple, woad. That's another yellow. Green, orange, black, gray, pink, white. I don't know. Somebody might. These are liquids, though, right? So I don't think. Could make a barrel recipe. Like if you wanted to build like a green plastic backing, you could do like a green screen effect. You'd have to make green dye and then dye the plastic. And that would be plastic blocks. So you dye the plastic blocks green by soaking them in a barrel in green dye for like a day. Right? And then you could... There's a bunch of colors missing from this, though, I feel. I just get the sense like he could have done way more with the dyes and the color, and he could have really added an amazing variety of colored clays and dyes to just make it make the game just a builder, crazy good builder system. Like not bricks, but like clay blocks fired clay. I guess there's no like terracotta clay. Everything is bricks. Planter, shingles, tile block. What is this? I don't recognize this. Tile. Earthy orange. I mean, he does have colors in here. Plain. Tile 2x2 plain. I think tile is... It's not a flat texture. And I know there's mods that, you know, the Bricklayers mod is crazy with the clay process and the fancy textures and colors and all of that. Now I'd love to be able to support that. I probably could figure out how to do a JSON system that, I don't know, detects whether or not, I don't know, is there a JSON, is there a built-in JSON that if a mod is loaded, then add a recipe, right? A recipe definition where the condition is like mod loaded with a mod ID or something like that. That would be really nice. Because if that mod is loaded, then boom, drop it in there. Or you could even do, you know, obviously the opposite of that. If not mod loaded, then add, you know, something that is needed or something like that. So cloth does this have colors? No. Carpet? No. I mean, there's colors, but it's not many. Turquoise is not even one of the dyes, so I don't know how to get that. Creative has, yeah, I know that Creative has that, and I do in my, I think my Buggy's Random Changes mod, I add recipes for the Creative Glow and Creative Light blocks with a crafting path to make them, because I thought they were awesome. Like, you could make like neon signs and stuff in the game, and I'm all about playing in survival. So everything I've always done is in survival mode. So I've not really ever done creative. So I wanted those recipes. I wanted to be able to make those light blocks in normal survival mode. So that's why I added recipes for them. But it's a very simple process. You craft the white, and then the white you just cycle it through all the different variations, and it's just a very simple thing. But for the like colored clays and stuff, or like the colored plastics, I think it would be a matter of just the dyes, making the dyes, and somehow figuring out like if I'm missing any. Tar, where does tar come from? Tar. What? When did they add this? Tar. Exclude true. Ah. blocks. Liquid. Tar is not a block. Okay, well, that is what it is. Block, wood bucket. Tar portion. Yeah, so there's no block of tar. It's, I don't know when they add tar. Like, this is new. But it's hidden from the handbook, so I'm gonna ignore it for now. But yeah, anyway. So yeah, I think this is at least tentatively ready for people to, test build it and figure out all the little bugs and issues. And things that I've forgotten, and just all the things. Because yeah, of course, there is probably a bit that I don't know, missed. I mean, theoretically, it should work. The only thing I haven't tested yet was this, and I'm kind of afraid to. So. Anyway, yeah, there's going to be a new public version. I really wanted to try to fix the damn fridge, because people are still telling me the fridge is borked in some way, but I don't know how, because I honest to God don't know what it is about the transition speed thing. Because the inventory of the fridge, if I go down to inventories, somewhere in here, inventory, fridge, update spoil rates. So this transitional speed by type, perishable food. So I'm setting the rates of these, right? And if we do a search, inventory generic, okay. If we do an analyze on that, is there a get used by? Try get value, food category. So if we look at the food category, protein, vegetable, grain, fruit. Okay, if we do enum food category dot grain, vegetable, protein, fruit, dairy. Dairy is not in here. Dairy. That's a new one. That's a new one. Now, did they set enum transition type dot dry harden convert melt perish cure harden what is convert? perish. So enum food category is another one of those like fruit, vegetable, protein, grain, fruit, vegetable, protein, fruit, protein, grain, dairy. Okay. Because somebody was saying that like a cooked meal and cooked meat, like something was wrong with that, right? So I don't know if when you place cooked meat, that should be a perish timer. It really should be. Inventory generic, get transition speed multiplier. This is what I'm doing. This inventory generic, transition speed, perishable factor by food category. That's what this is. Transitional speed multiplier by type. That's what this is. Invoke transition speed delegates. Food nutrition properties. Get nutrition properties. Bridge perish, like get default transition speed multiplier. I don't know. If transition equals perish. What actually updates? Let's look at food spoil. Reiterate this as object. Okay. Perishable food. But if we look at maybe collectible object, get spoil, get get transition rate. Rate, get transition speed multiplier. This in slot that inventory. Get transition speed multiplier. What tracks the spoil parish constant parish rate container? Get parish rate. In-world container. In-world container. This is why, like, people are talking to me about, like, the fridge is borked. This is why. This is not easy to track. Like, what actually drives the parish rate, right? Analyze, used by, used by, on acquire transition speed. This is the block entity. Okay. On acquire transition speed in the block entity. Go to the block entity. Transition type. Transition speed multiplier. Event can only appear on the left-hand side. On acquire this inventory, on acquire transition speed, plus equals parish rate. Like, why do I, if it's defined here, why would I have to do anything like this? Shouldn't that automatically just take into account? Okay, well, let's do this. I'm just going to copy this for now and paste it here. Okay. Bool flag equals trans type equals dry or melt room return room does not equal null and room.execount equals 0 room this dot container dot room exit count equals 0. And return equals 0. Return 2. So if it's dry or melt, and there's no exit, and it's in a room, I don't know what this exit count is, though. Like, how do you have a room with no exit? And why would it melt faster? But if there is an exit, then it's 0.5. Because if this is true, then it uses this. If it's false, it uses this. So if you're trying to dry or melt something, transition speed, put it in a room with no exit, that doesn't dry stuff. That would do the opposite of that. Transition speed ripen. Like dry melt. How about we do this? Inventory, transitional speed multiplier by type. Times equals. See, this is on acquire. So this is adding something. So this multiplied by config is something that can get multiplied through many different things, right? So you have many things applying a possible modifier to this, including the weather, including a bunch of, like, whatever the game is doing on behind the scenes here on this call. Math.clamp. Container get parish rate. One minus parish rate minus 0.5 times 3 as the value. Clamp it between 0 and 1. 1 minus parish rate minus 0.5. multiplied by config times inventory transition speed by type. So what happens if inventory dot transition speed by type dot contains key trans type? Right, just in case it's not in here, whatever it is. Okay. Again, like this, I'm just kind of hacking away at this because there's some combination, right? There's some combination of like, what the hell do we do with this? Get parish rate container, get parish rate, which is this. It's weird. If this AB null or inventory equals null, to state on don't get parish rate, get default transition speed. Inventory base. Get default transition speed multiplier. If transitionable speed multiplier by type dot contains key, return else return 1. Used by yeah, and then it would invoke the delegate here, which, right, this invoke transition speed delegates is what is being on acquire transition speed. So it's pulling the multiplier, transition speed multiplier. Then it's invoking all of these, which would double dip, right? This would double dip on the transition speed because this is already setting, hey, this is the transition type. Pass it along. So get transition speed multiplier used by where is collectible object temperature dummy inventory unacquired transition speed. Get transition speed multiplier. There's wait. Get transition inventory. Get transition speed multiplier. Not get default transition speed. Where's the get transition speed multiplier? Okay. Let's delete that because it's ugly and bad. Override. Get transition speed multiplier. Literally the same thing here. Get containing transition modifier contain. What? Delegate. Why do you have an empty if statement? I wonder what the source code looks like because that is really weird. Num2 times get containing transition modifier contain, which returns 1. Okay, so it's 1 times this num2, which should give me a really small number, right? 0.05 or whatever it is. Parish. Append parish info text. Get transition rate multiplier, transition state, parish. This dot state dot props. State. Transition state. Transition state. Array. Updating. Get transition state. You can see the rabbit hole, right? You can see like where are these data? Where are these points coming from? This is crazy. Why can't you just write to the attributes? Why does this have to be so hard? Just write state or whatever, transition state or something. Like do something. Update and get again. We're nesting the calls. Okay, I'm just gonna back out of this. I don't want to get the invoke. I don't want to double dip on my transition state. So get transition speed multiplier here, and then get default. Right. So get transition speed multiplier calls get default speed modifier. But I don't really need to do that. I could just, yeah, And then I don't want to invoke anything. Maybe? I mean, yeah, I don't think I might need this. Because this one just returns ones, right? Regardless of the transition type, it returns ones. So multiplier will be 1. And then invoke transition speed delegates. This is going to call get default, which is what we have here. So our version of this, right, multiplier should be a much smaller value. And then the invoke, that may not have anything in it, right? Because the on-acquire transition speed, right, the add might have some stuff in it, but it shouldn't. It's going to take our original multiplier, which should be less than 1 originally, and then it should apply whatever shenanigans are here. But perishable factor, the perish rate, right, is what we're kind of paying the most attention to. So like what the croc here, block croc, if I config add equal null, get containing, return 1. So it's just going to return 1 regardless of what this does. This literally multiplied by 1. So what's the point of subscribing to that in the first place? So the shelf here does some gubbins. Get content in dummy slot. Get containing transition modifier. Where are the perish timers at? Where are they used? Perish info text. Perish state. Transition state. It's almost like it ignores the different perish rates for the different items. Because I don't know where the perish, where these are used or looked at. Get inventory generic. Get transition speed multiplier. Transition type and this dot perishable factor by food category. This is in the inventory and get transition speed multiplier. Okay. Condition prompts. It tries to get, okay, so that If otherwise not a rate multiplier. So that's, yeah, that's right. If it doesn't exist, then set it to 1. If it does, multiply the value, right, by that multiplier. If is not null. Yeah. What's funny is this double dips the parish speed. The default game double dips the parish speed. Right? Because this if trans type equals parish and perishable food, okay, so you're setting the perishable, let's say it's grain, right? A storage container for grain. Well, you're multiplying the value, the multiple, right, which is the default speed, which if you don't override it is 1. So it multiplies that by whatever your transition is. But then it looks to the next one, transitional speed multiplier by type, which we've already looked at, which is the parish. Trans type is parish, which is the transitional speed multiplier by type. So if that's not null, which it wouldn't be if you've set it, then the rate again is multiplied yet again. You're double dipping when it's parish rate. If it's not parish, if it's like dry, then this wouldn't hit, but this one would. But parish double dips. It sets it and then it sets it again. Or it multiplies it and then it multiplies it again. Right? And then you invoke any of the delegates, which could multiply it again if you're not careful. So I don't know if this I think would need an else instead of an if, which would prevent it from double dipping. Because if this is true, do the multiplier. But if this is not true, then just do a generic transitional speed. Right? Transition speed is parish and perishable food category is not null, and nutrition props, which is what you're getting from the item. Right? That's the stack of what you're passing in. So it just is what it is. I don't understand why it has to double dip here, but it is. It's 100% double dipping here. Build, rebuild. Okay. One last test and then we'll be done. Because I want to send this out to, new community build, new public build, and, I want people to actually be able to use the thing as much as possible. Give block VELV fridge. Okay. Storage vessel. Doesn't matter. Give block storage vessel loam. So this is unpowered. That's important. It's not powered. Let's grab some LV wire. Get her plugged in, and now you can see protein 0.05. So it knocked everything down. Okay, so now we want to give ourselves some food. And dear Lord, do I have a lot of gubbins on me. Okay, so cooked red meat, give item 10 of those. This is fresh for 5 days. Fresh for 4 days. Fresh for 5 days. That's funny. Because this, as you can see, does not have protein. Food category protein. So other, 1.25, that's why this is less. Right? Whereas mine is 0.25 or 0.05. But I have, yeah, it should be 0.05. Fresh hours, 120. Transition hours, 12. Remember, these are these are conversions of daytime to like real time. So 12 hours of game time would be 3.6 years. No, is that right? That's not right. Fresh hours. Oh, there it is. Fresh hours, 120. So that's 120 hours of real life time, which is 3.6 years in game. 120 hours is a lot. And then this, transition hours 12. Okay. So now, if we do time add 24, days, 3.6 years. Well, yeah, it goes up and down because of the temperature. Slightly. So if we add again, 2 days, 3.6 years. So that works. Now it's 3.7 again. You'll get little bits here and there. Now 0.05 might be, pushing it. That might be a little too much, but extreme values are much easier to calculate. So fresh for 3 days, this should be 2 days, yeah. Because remember, this is 1.16 because there's no protein. There's no protein line item here. There is over here. This has got all the things. Okay, so then we want to see bread. We actually have some bread. So fresh for 5 days, pop it in here. Fresh for 9 days. Okay, that's this. Fresh for 9 days. Because now we're getting the 0.57. So 5 days to 9 is, right around there. So 5 days. Now we should have many days. 3.8 years. Okay, so this transition hours, you can see 0.5. I don't want to skip too much time because I really don't want winter to arrive too early in my test world here. So yeah, this is now 9 days. So one more time add 24. Now it's 8 days, and this is not changed. I mean, can I call it fixed yet? Can I please, pretty please call it fixed? Outside of like meals, like give handbook meal. Okay, so it's not an pot pie. Yeah, there's no like way to give myself a meal that I know of. So maybe I can do this? No. Damn. Okay. It's been a hot minute since I've made any food. Usually it's Oz that makes all the food and he's so good at it. He's only poisoned me a couple times. Yeah, because I would need to like bread and then line it and then all the things and then bake it and then now I'm hungry. This has made me hungry, everybody. Let's see. So grain should be crazy. Grain dash rice 40. So this is fresh for 90 days. Okay, so in the storage thingy, this has got a 0.79 multiplier. So that's 1.2 years. 0.53, sorry. 0.53. So 90 days, which again is 10 months, right? It's 9 days a month. So 90 days. It's not 3 months, it's like 10 months. So this going in here, 1.2 years, is yes, another 50% on top of that. But if we put it in here, boink, 74 years, which is really good. I think I'm going to go out on a limb and say it's fixed. I don't know what else to do. It's the trends, like they're all there. I don't know what else to do. It works. Like I've even skipped days. I've skipped too many days. I've skipped 3 days. For some reason, I completely skipped day 7. I don't understand how. Oh, ha! I skipped 7 because it 23:59 literally, and then a day it goes fixed to 7, and then boom, I do it again, and it's 8. That's funny. It just happened to be midnight when I triggered. Now, if this thing runs out of power, bad stuff happens, right? The perish speed flips to 5x, and you're going to have an unpowered fridge. If a creative person out there realizes it, an unpowered fridge is a rapid spoil machine. You can spoil stuff incredibly fast with an unpowered fridge. So just saying, if your point is to try to decompose some rot, unpowered fridge is the way to go. Just fill it full of stuff, and not long. It's like a 5x multiplier on that. But yeah, anyway, that is going to do it for today, everybody. I think we have something, at least semi-testable. At least semi-testable in the game. So, it's tentative, and I'm sure I'll hear about it if it's not. But at least we'll be able to, get people with hands-on, experience on there. And I'm sure I'll have a myriad of little bugs here and there to deal with, but it is what it is. Now, if you put that fridge in a cellar, if you dig down and you build yourself a little root cellar, and you put the fridge in that and power it, you're going to get even better storage because it's in basically a temperature-controlled environment. So, but I'm gonna again officially call the fridge done because I don't know how much more I can take of the fridge. But we're gonna do a final rebuild here. And I've already bumped the version up, but yeah, look for that dropping here in the next few hours. And should be, if you're watching this later on, 0.5.8 should be uploaded. So, I just have to get it all zipped up and get everything done and all that kind of stuff. So, thank you all for coming by. Please hit that like button if you enjoyed yourself or if you learned anything today. Hit subscribe, and yeah, consider being a patron or channel member or commissioning. I've got some commission work to do, so then that's going to be the next block that I do is a little bit of commission work. Somebody commissioned some work, so I'm gonna focus on that for a little bit because the stuff that pays is more important than the stuff that doesn't. So I have to kind of prioritize. On Saturday at some point we're gonna continue our V-Rising. I'm just kind of having fun with that, so we'll continue that on Saturday. But otherwise, have a great rest of the week, everybody, and yeah, go outside.